So friends, now we'll see the schematic diagram, like what happened after power button press. That means which are the voltages are generated, that we'll see. So what we can do is, first we go the SIO page, and after that I'll show you which are the buck converter turn on one after another. So I'll go to the next page, and we'll see where is this SIO. SIO, here is the SIO, here is my SIO. The page number is a 58 and SIO number is a ENEKB9052. So this SIO is a programmable SIO. So what I'll do is, I'll go to the page number 58, 58, 58. Okay. So here is my SIO, and once the SIO receive this SLPS3 and SLPS4 signal, then SIO generate the three output signal. So this is basically a compil motherboard. So compil motherboard generate SL, CSON, SUSP and VRON. Normally, if it is a quanta motherboard, then the signal will be SUS on, main on and VR on. And if it is a Westron motherboard, then this all voltages are generated one after another, like SLPS3 and SLPS4 signal only given enabled to this all the buck converter one after another, like it's called the cascade system. They are like a turn on one after another. Okay, they turn on each other. But this motherboard is a compil motherboard. So in compil motherboard, normally this signal turn on by the SIO, signal name is CSON. So we'll see where is this CSON. I'll just go to find, and then I type here CSON. Then I'll search, and you can see here on the SIO, this CSON signal generated by this SIO, and this is a pin number 95, and this is going to the page number 78 and 86. Okay, so we'll see where this signal is going, and CSON signal is basically going to turn on the RAM supply. So here in this laptop, the DDR4 RAMs are used. So DDR RAMs require a 4 level of voltages, that is 1.2 voltage, 0.6 voltage, 2.5 and 3.3. So there are the 4 voltages are required to the RAM chips. So we'll see where this CSON is going. It's going to the page number 78 and 86. So we'll search here. It's going here, then going here, here, then we'll zoom out, and you can see this is page number 86, and this is a chip number is RT81207, and this chip is basically a generate power to the RAM. So here you can see the 1.2 voltage, then this 1.2 voltage is going to the RAM, and this here is a chip. This is the location of the chip is a PUM1, and the chip number is RT8207PG. Okay, and this is basically 20 leg chips. Okay, and here this CSON signal coming from the SIO and is going to the pin number 8 of this chips, and this is an enable signal, and once this chips get the signal, then it started switching this 2 MOSFET, and then the output 1.2 voltage will be generated. So it's like that. Okay, so in this way this RAM voltage will be generated by the help of CSON signal, right? So we understood the CSON signal, and we'll go to the next. We'll go back to the SIO. Okay, after CSON there is one more signal generated, that is SUSP. So here is a SUSP signal. You can see here pin number 116, and the signal name is SUSP. So what I'll do is I'll select this signal. I'll select like this SUSP. I'll copy this. I'll cancel the previous signal and paste it a new signal, that is SUSP. This SUSP signal also generated by the SIO, and this signal is going to turn on the PCH power supply plus the RAM VTT voltage also. So I'll just select this SUSP, click on the next, 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 and you can see here, so here are the two switches are there. You see SUSP, SUSP, and here is the switches are your switches are used, and what this switches do is, this voltage, the 5 voltage is the always voltage, 5 volt always, ALW means always, okay, and this 5 volt is a sustained voltage. Here is a 3 volt always, and here is a 3 volt suspend, okay. So once SIO generate this SUSP signal, and what happen is when the switch receive this enable signals called the SUSP signal, then what he do is he just transfer this 5 voltage to here and transfer this 3 voltage to here. So this is a basically a generate a barrier, okay. So it's a barrier, and once SIO send this signal SUSP signal, then this voltage will cross this barrier, and this voltage will become 5 volt suspend, and here is become a 3 volt suspend, okay. So this SUSP is called suspend on, and this turn on both the switches 3 volt and 5 volt, and we'll see where is the signal is going next. It's going so many places, but yeah, see SUSP signal same, it came again to the RAM section where the 1.2 voltage is generated. Now you can see here are the two input, one is called the CSON. CSON signal is going to turn on VDD voltage for the RAM, that is a 1.2 voltage, and here is a one more input signal that is called a SUSP signal, that is also coming from the SIO, and this is going to turn on the RAM VTT voltage, okay. So how the VTT voltage is basically half voltage of the RAM. So here is a DDR4 RAM, that is a 1.2. So VTT will be 0.6 voltage. So here is a linear regulator. So these chips have a buck converter also and the linear regulator also. So the 1.2 voltage which is generate, this is going to the RAM, and simultaneously this voltage going to this chips also at pin number 5, okay. And once this chips receive this SUSP signal, this enable signal, then at pin number 20 this 0.6 voltage, that is 0.6 voltage will be generated, and this voltage will be the VTT voltage, okay. So it's work like that. So this is a VTT voltage, okay. So after that this voltages are generated, and then we'll go to the next sections. This 1.05 voltage will be generated. So this is a 1.05, okay. So 1.05 there are also a buck converters, and after that SUSP signal, the final signal that we have to check, that is a VR on signal. So we'll see where is this VR on signal is. So SUSP lead switch is C on, then you can see this VR on signal. So what we'll do, we'll select this signal VR on, we'll copy this signal, then cancel this, we'll paste here, and then we'll click next, then next, then next, then next. We'll click next till our CPU core chips. So what is this? So this is basically a CPU core chips. Yeah, this is a CPU core chips. The chip number is RT3612. Location of the PUZ1. Okay, and this chip is a VRM chips, okay, which generate a CPU core voltage, okay. So this is this VR on signal coming from where? This signal is coming from SIO, okay, somewhere around 1 to 3 volt. So once this receive this voltages at pin number 23, then this chip started functioning. This pin number VCC, that is a 5 volt, and V in pin is a 19 volt, and the output voltage will be a CPU core voltage will be generated, okay. So it is like that. So friend, in this way we can see this all voltages will be generated. So after CPU core voltage will be generated, then the PCH or the SIO will not a PCH, SIO will generate system power okay signal or the system power good signal. So we'll search that signal. It's called SYS PWR okay, system power okay signal. So this signal we have to check. So this signal is generated by the SIO. See, this signal is generated by the SIO at pin number 74. So what do you mean by this signal? The system power okay signal or the system power good signal mean the signal that your all power planes are okay, like your 3.3, 5, 1.2, 0.6, 2.5, 1.05 and CPU core. So all when the all voltages are stable, then only this signal will be generated. So friends, so this is a very important signal. You have to remember that if you want to check whether my all voltages are coming or not, for that you need to check the signal system power okay signal. So system power okay signal is a very important. So you have to check whether motherboard is a compile, quanta or Wistron. So all motherboard generate the system power okay signal. So you have to check the system power okay signal, and if the system power okay signal is coming, then that means your all powers are okay. So understood? So in this way we have to check all the signal, and after system power okay signal, the PCH or the CPU will generate the PLT reset signal. It's called PLT reset, PLT RST. You can see this signal. So you can check this signal. It's going, it's a generated by the CPU, and this signal is going so many places. So you can check this signal PLT-RST. Here is a PLT underscore RST. Okay, so you can check this signal. You can check on the SI also. It's coming on the SI also, or you can check anywhere which is a convenient to you. You can check here also. This is the AND gate. You can check here also, or you can check on the SIO also. I'll show you on which pin it's coming on the SIO. Just wait. This is not the SIO. We'll go to the SIO and we'll see. I'll tell you where you'll check this PLT reset signal. Wait. SIO is on somewhere around. Yeah, this is my SIO, and the PLT reset is here somewhere. So this signal is a name little bit different. It's called SPI underscore RST. Okay, so you have to check this signal and pin number 14, and if this signal is coming, that means the PLT reset is perfect. So you can check either SIO or anywhere which is a convenient to you, and if this signal is coming, that means the CPU generate the platform reset signal, and after that the clock will be generated, and then CPU start accessing the BIOS. Okay, so I hope you understand the concept of the schematic diagram after laptop turn on. Okay, so thank you very much.